Okay, so moving to the next question. So which is we will solve a question about the trigonometric functions. So let's say if we would like to solve question 11 or 12, both of them the same trigonometric functions. So I will try to solve question 11. So in here let's choose the pen. Okay, so in here question 11. So let's say we have the domain for the trigonometric functions for sine and cosine. Actually it will be from minus infinity to infinity, which is r, but in here in the question they restricted the domain to be from 0 to 2 pi. So the domain originally it's from minus infinity to infinity for sine and cosine, but in here I have to stick with the question, so it will be from 0 to 2 pi, and both of them included 0 and 2 pi. Now I have to find the derivative, so product rule. So the derivative of the first one, which is cosine x, multiplied by the second one, which is cosine as well, so cosine square over here, then a plus in here the derivative, or I'll put back the first one again, sine x multiplied by the derivative of the second one, which is minus sine, so it will be sine here square, and this is the minus there. Okay, now make the derivative equal to 0, so that will give me cosine square x minus sine square x equals 0. Now move the sign to the side, so cosine square x equal to sine square x. Now divide by cosine square x and divide by cosine square x. That will give you 1 over here, and sine square over cosine square is equal to tan square x. Now take the square root of both sides, then don't forget the positive negative, so tan x is equal to positive negative 1. So in here I have, from tan x equal to positive 1, I can find tan inverse of positive 1, and from the second one I can find tan inverse of negative 1. So what is the answer in this case, and what is the answer in this case? So directly go to your calculator. So in here I will choose shift menu. Okay, wait again. Yes, shift menu, then convert your angle unit to be in radians. So in here I'll start by converting the unit to be in radians instead of degrees. So this is 2, so now it's in radian. So now I will write tan inverse, so shift tan, and I will write 1, then that's it, it will be pi over 4. And for the second one, let's say we have minus 1, so that's negative. So in here I have tan inverse of minus 1, which is minus pi over 4. So in this case I have pi over 4, and in this case I have minus pi over 4. Okay, now for this, all the time for tan, add for your final answer n pi, because it's periodic function. So in here the angle, it will be pi over 4 plus n pi. Now because my domain is restricted to from 0 to 2 pi, so I'm not going to find all the angles, okay, outside the 2 pi, because they are not included in my domain. So I'm just going to find the angles that they will be included in my domain. So first of all, let's substitute 1 instead of n. So pi over 4 plus pi over 4 plus 1 pi, which is equal to 5 pi over 4. and this is included in my domain, which is 0 to 2 pi, because the 5 pi over 4 is inside this interval. Now I'll try to add 1 also. So pi over 4 plus 2 pi, okay, which is equal to, in here, 5 pi over 4 plus 4, okay, so which is going to be 9 pi over 4, and this angle is not included in my domain because it will be greater than 2 pi, so I'm not going to accept that. Okay, what about, so in here I have pi over 4 and 5 pi over 4. From this, minus pi over 4. Minus pi over 4 is not included in my domain because it's less than 0. Okay, so let's add n pi for it. So minus pi over 4 plus n pi as well. So minus pi over 4, let's take 1 plus pi. So that will give me in here 3 pi over 4. And this is included in my domain because 3 pi over 4 is between 0 to 2 pi. What about minus pi over 4 plus 2 pi? Okay, so in here plus 2 pi, so this is going to be 7 pi over 4, which is going to be also included in my domain. If you try to add one more, which means minus pi over 4 plus 3 pi, for example, the result, it's not going to be included for this interval, which is from 0 to 2 pi. So in here I have, for sure this is rejected. The second one, which is a 3 pi over 4, this is accepted, and the 7 pi over 4 accepted as well. So I have 4 angles, 1, 2, 3, and 4. These angles are included in my domain. So these are the critical numbers. Okay, I have over here. Done. Okay, so these are the zeros. We have found them. So if we have local maximum, local minimum, so directly I'll go ahead and just choose the line. So grab the number line. Okay, so we have our interval from 0 to 2 pi. Then we have to write them in the correct order. The first one is the pi over 4, and the second one is 3 pi over 4. Then we have 5 pi over 4. Then we have 7 pi over 4. Now we have to substitute. By the way, this is in degrees. If you would like to substitute in your calculator, if you would like to convert any angle to degrees, so this is 45 degrees, this is in here 135, and for 5 pi over 3, 225 degrees, and this is 315. If you would like to substitute in the calculator, you'd substitute in cosine square minus sine square, any value between 0 and 45. Be careful that you have to put your calculator in degrees, for example, or keep it on radians, but put any value between 0 and pi over 4. Or if you would like to use the radians mode, so you can substitute any value between 0 and 45 in cosine square minus sine square. So after substituting and finding the value of the function, this is going to be positive, this is negative, this is positive, and in here negative, and in here positive. So in here we have upward, downward, up, down, up. So at the end I have local. Okay, so local maximum at pi over 4, and we have 5 pi over 4, Okay, 5 pi over 4. Okay, then we have what? Then we have also local minimum. So this is local minimum at 3 pi over 4 and 7 pi over 4. That's it. Next, inshallah, we will solve questions about in here rational functions.